Hello, Professor and everyone. Today I will present my project idea, spam detection using Naive for task classification. The main purpose of this project is to detect whether an email is spam or hand mean not spam. Spam messages are becoming a growing concern, especially in email and messaging platforms where they cause inconvenience, risk, and sometimes lead to financial loss. A spam detector helps improve digital communication and enhance user safety. I would like to introduce my project overview. The project is developed using Python and several powerful libraries and frameworks. Scikit-learn was used to build the span classification model. I chose the multinomial naive logarithm, which is well suited for text classification tasks. NLTK was used for text preprocessing, such as removing store words, punctuation, and stemming the word. Pandas help me load, clean, and handle the dataset efficiently. And finally, I use Streamlit to build a simple and interactive front-end so users can type the message and get instant spam classification result. This combination of tools allow me to build a complete spam detection. I would like to explain the dataset I use for training and testing my spam detection model. I use a dataset from Kaggle that contains around 5,000 labeled email messages. Each record in the dataset includes a few key fields: the subject of the email, the body of the message, and a spam label which tells us whether that email is spam or not. These labels are in binary format. 0 means the message is hand or not spam. 1 means it's a spam message. This label data is crucial because it allows us to train the machine learning model in a supervised way, where the model can learn to differentiate between spam and non-spam based on real XML. In this train model of Wi-Fi, I import essential tools from Scikit-learn and NLTK to process and analyze test data. df-IDF factorizer converts message into numerical file. It helps the model understand the importance of each word across all messages. I use multinomial naive model to train the spam classifier and store word along with Potastemma. Help clean the text by removing common words and reducing words to their root form. In this utility Wi-Fi, I use NLP pre-processing techniques. I converted the message to lower case to standardize it. Then I remove all punctuation so the model focuses on word. After that, I filter out stored words, common words that don't help classify spam. Finally, I apply stemming to group similar words like playing and play are both reduced to their root form is play. All these steps ensure the text is clean and meaningful before it goes to the model. In main.py, my first API backend handles prediction. To ensure consistency, I reuse the same pre-processed function from training. In the training script, the function is used directly. In main.py, I modularize the code by moving pre-process to util.py and importing it. This makes the code cleaner and more reusable. Finally, I classify the message using model.predict within a REST API endpoint. This is how I ran my project step by step. After running the backend, we can see these two files appear in the model. And also, it confirms the first API backend is working. In the front end, I use Streamlit, a Python library that makes it very easy to build interactive web apps. It collects the user input, sends it to the Fast API backend for prediction, and displays the result in a clean and style format. The htdoc prefix just a shortcut to access Streamlit feature like button and markdown element, making the user interface both functional and intuitive. I ran my front end. We can see this checkout. And also we can use from the browser. I started testing my project now. I copy the mail and I click the check button. It shows hand, it means it's not spent. Why do prediction hand in green? And also it shows the probability is 23.6%. I test next email. After I check the button, it shows hand. The probability is different. Now it shows the 1.88%. I will test next me again. Click the check button. And also it shows hands. It means no spam. And also get a very low spam probability, 0.444%. It shows that the model correctly recognizes real, meaningful communication. I will just next mail again. This message as spam probability is high, 92.8%. Why do prediction spam in red? I will test the next message again. Now I check the click button. It shows the prediction is spam, and also the probability is different with previous one. The probability is 67.3. I will test the last message again. Okay. I click the chat button. The prediction is span and also the span probability is difference. The probability is 82.4%. In conclusion, I summarize the key natural language processing technique applied throughout the project. Lowercasing, I convert all characters to lowercase to maintain consistency and avoid treating the same word differently due to case difference. Removing punctuation. Punctuation often doesn't carry meaningful information in span detection, so I eliminate it. Tokenization. This is where I break down text into individual words or tokens to make them analyzable. Store word removal common words like there, is, or and that don't add much meaning I remove. Stemming, I reduce words to their base form, so words like running and runner both become run. Finally, I convert my clean text into numerical data using df and df, which give more importance to unique, meaningful words in the dataset. This NLP technique forms the foundation of my span detection system, enabling my machine learning model to make accurate prediction by combining pre-processing, feature extraction, and a trained classifier. The project successfully demonstrates how natural language processing can be applied to a real-world problem. Thank you for listening.